Dear students, today we will discuss the topic monostable multivibrator. In the last lecture, we have discussed the functional diagram of 555 timer. If you have any doubt in the functional diagram of 555 timer, I have given the link in the description box in this video, so we can refer that. So today we will see what do you mean by monostable, what is a functional diagram, and I will teach you how to draw the circuit and you can practice along with me. Okay, if you have any doubts you can discuss in the class. Right, okay. What is a special thing in the monostable multivibrator? The thing is here in the monostable I need to give the trigger. Consider this is a circuit. This is a circuit. I want to give the trigger. So what happened when you give the trigger? You'll get one high output. Again it revert back to the original state. So this is the output because of the triggering input. So that's what they said. It produces a pulse. The pulse at the output. This is output. And return back its stable state. This is a stable state. The duration of the pulse is depends on the value of R and C. So the another familiar name for monostable multivibrator is a one-shot multivibrator. Very important to understand. It is also said to be the one-shot multivibrator. So the monostable means I want to give the trigger to get the logic of high and return back to original state. If you give the trigger again, you will get the another high state. This is a logic you want to understand. Okay, so this is a circuit. Okay, so this is a circuit of the monostable multivibrator. So here you can see this is a 555 timer. See, in the last class I explained with the pin details, right? So the second pin is your trigger and fifth pin is your control voltage and one is your ground terminal and third is your output and sixth is your threshold and seventh is your discharge and eighth is your supply voltage and fourth is your reset. Here I am doing some modification. See, you can see here in the fifth terminal the capacitor is connected. We know that is a control voltage. If you are not using, you want to connect on capacitor with the ground to avoid some noises or some ripples from the DC voltage. So this is a thing we learned in the previous lecture, right? So trigger input you will be applying in the second input. This is about the left side. In the right side you will be getting output. This is your output you will be getting from here. And 6th and 7th are shorted. You know that 6th is the threshold and 7th is the discharge. So that both should be connected to this RC network. This is something a simple RC network. So the 8 and 4 are shorted and given with the DC supply. Okay, so this let me draw the circuit. Okay, so let me draw the circuit and explain you how your logic is working so that you can practice along with me. So if you have paper you can take it. Okay, so you can parallelly you can practice with me. First what you can do is first put the divider network. We learned in the functional diagram. I explained you about the divider network, right? So first put the three resistors. The first give some gap. Okay, this is your supply voltage. You want to give VCC here. This is called divider network, right? Then connect one RC network. Okay, RC network. Connect this capacitor in the down. name the elements. RC, this is 5K, this is 5K, and this is 5K. Now we have a two comparator. This is our upper comparator plus this is a non-inverting and inverting terminal. So name it as upper comparator. Here you have a lower comparator. Non-inverting, inverting, this is a lower comparator. So this should be connected to the flip-flop. So I hope you practicing parallelly. So this is R, this is your S. So this is your Q and this is your Q bar. Okay. So now connect. You take a two branch from here. One terminal for connecting the reset, another terminal for connecting to the discharge. Okay. So from here you draw on NPN transistor. So name the terminals emitter, base, collector. Give the name for this transistor as Q1. The emitter terminal to be grounded to this terminal. So complete this. So keep dot. And the collector terminal. So collector terminal. So you take this collector terminal and connect in the capacitor network. Okay. In the top, see, this should be connected, this end to be connected to the collector terminal of your PNP transistor. This is your emitter, this is your collector, this is your base, this is a reset pulse. So this is a VREF. So you can give some name for this Q2. Okay, from here we are taking output. Power amplifier, then you will be having your output. Right, now we will connect the comparators. The upper comparator, the positive terminal will be connected to the RC network. Right, so the upper, you can note down, the upper comparator positive terminal is connected to the positive terminal, to the comparator non-inverting terminal. The upper comparator negative terminal will be connected to this network. Okay, this is biasing 2/3 VCC. So that is going to the inverting terminal of your capacitor. Right. This is a pin number U. This is a 5th pin. This is a 6th pin. So note down the terminal. This is a 7th. Okay. Now we will connect the lower comparator. The lower comparator plus connected to this 1/3 of your VCC. Okay, you can see here in the upper comparator minus was connected, in the plus comparator plus was connected. So we know that the comparator, the plus voltage should be higher than the negative voltage to get the logic of 1. That we should remember to understand this comparator principle that we learned in the previous video, right? So the minus, where it will be connected, minus is your triggering input, right? So the minus I will be connecting, taking from here and not connecting. See, the connecting means this is the connecting. If I am not connecting means I will be putting like this, right? So that means I am bypassing this node. So here also I am bypassing I'm bypassing and I'm giving a trigger here 2. 2 is a triggering point. Is a triggering point. So that is 1 by 3 VCC. So this is a threshold voltage, right? So this is your diagram, right? So this is a functional diagram. I hope you practiced parallelly along with me. So I already explained you the terminal names, right? So the 6th terminal is your threshold, and the 5th terminal is your control voltage, and the second pin is your triggering point, and 7th pin is a discharging point, and this flip-flops are connected. This is a Q state, this is a Q bar state. The output is given directly to the power amplifier, then you will get the output. This is a time duration T. This is connected to PNP transistor. This is a PNP transistor. This is NPN transistor. So you can encircle this. Also you can encircle this. Okay. So this is about a circuit. Now we will see the working principle. How it's going to work. First I will be explaining you here in the circuit. Then I will put the flowchart. Okay, that is giving a clear idea. Initially what happened, you know, it is in the standby state. You understand? What do you mean by standby state? That is a question will rise, right? So like the flip-flop initially will be in the state of Q. The Q bar will be 1. You can see here when I am giving 1, this is connected to this Q1. That means the transistor will on. The transistor will on and it is connecting, that is connecting this capacitor, right? So that means it will be going to the on mode, right? It is going to on mode. So that means it will clamping the external timer capacitor to the ground, right? Because this circuit will be short circuited and it is connecting to this capacitor. So it will discharge, right? It will discharge completely to 0. It will discharge completely to 0. So it will discharge through this path. It will discharge through this path. Through this path. This is a discharging path. Okay, it is a discharging path. So why it is discharging? Because this, when it is on, it clamping the external timer circuit, it is a timing capacitor, to the ground. So it will completely discharge to 0, right? So now your output will be 0 completely. If you see here, your output will be completely 0. That is the initial state that you want to understand. Now when I am applying the trigger, please understand, when I am applying the trigger, right here the plus is connected to 1 by 3 VCC, minus is given to the trigger, right? So when this trigger input is less than this 1 by 3rd of your VCC, this, because this should be higher, then only your lower comparator will on, right? That is a situation 1. When the 1 by 3 VCC is lesser, so that means your trigger input is, the trigger input is less than your 1 by 3rd of your VCC, right? So that time what happen? This will on. This will on, right? That means Q will be 1. Q bar will be 0. This make your Q1 transistor to off. Q1 will go to the off condition, right? So before it was short circuited, now it will be releasing the short circuit. So it will go to the cutoff mode. right? It is going to the cutoff mode and it will charge. So now it will be disconnected, this circuit will be disconnected from this element. So it will charge. How it will charge? So it will charge like this. It will charge through this external timing circuit. It will charge, right? Your capacitor will be keep on charging, right? Keep on charging. So when it will change, right? So you can see this in the upper comparator, the plus terminal was connected in the same RC network. So when your capacitor voltage is reaching is greater than 2/3 of your VCC. So what happened? Your capacitor voltage is greater than this 2/3 of your VCC. Your upper comparator will on. That's all. Will on. So that means you will be having a reset of 1. When it is reset is 1, S is going to 0. If R is 1, you know that Q state will be 0, right? This will be 1. So this will be again is going to the on state. So that means again it is clamping, right? It is clamping the timer circuit to the ground. So it will start to discharge. It will start to discharge through this path. So please understand the charging is this path. This is your charging path. This is the charging path and discharging path is this is the discharging path. So the discharging, you can see this is discharging. So immediately you have discharging. See, you want to notice one thing. The discharging is happened because of this capacitor. There is no other resistor, right? Only because of the reactance of this capacitor, this is discharging. So you know that this is giving 1 from this logic of Q bar. So the transistor is on. So this is clamping the external timer capacitor circuit to the ground. So it is discharging. So this is like a stable state. This is your next state. This is your next state. Okay. So this here actually discharging is fully happened. Here you are getting the, when you are applying the trigger pulse, what happened? You are getting the higher state. Then again it is discharging and going to the stable state, right? So this what it is working. So this process will happen continuously and you are getting a one stable state, and if you give the trigger you will get a monostable state and again come back to the stable state. So if you are giving the next trigger, again it go to the one higher state and again it's going to the stable state. So this is what this is working. So let me go to the like a clear explanation. I'll be writing you some important points you can note down. Initially it will be like a standby state. Okay, so that is a standby state. So what happened here is we clearly learned like a Q will be 0, Q bar will be 1. So this is going to Q1 transistor, that is logic of 1. So that means your transistor will be on, right? Will be on. If it is on, this will be like your external RC circuit will be connected. So this capacitor will be connected. This capacitor used to discharge. So discharging has happened because of the external timing capacitor. External timing capacitor to ground. So discharging. So it is discharging through this capacitor. Okay, now your output will be 0. Okay, so I hope you are clear. Now I am applying the trigger state. So So we know that like a when trigger input is, because your plus is connected to 1/3 of your VCC, right? Your plus is connected to 1/3 of your VCC. So it should be higher than the trigger pulse. If the condition is satisfied, the trigger pulse should be less than this 1/3 of your VCC. That is the same. If it is satisfied, what happened? Your R S will be 1, R will be 0. So because of this, the Q state will be 1. So Q bar will be 0. This is sent to the transistor. So what happened? This transistor is acting as a off. So the external timing capacitor circuit will be disconnected from the previous state which is connected, right? So now what happened? Now we used to charge, right? So used to charge through this network. So you used to charge from the supply. So you used to charge. So you used to charge. So output will be, so capacitor output will be something like this. Your output will be something like this. So this is a capacitor voltage, this is your output voltage. Now, so the capacitors keep on charging. It is the next state. If your capacitor voltage is greater than 2/3 of your VCC, so what happened? So that time your upper comparator will on. That means R will be 1, S will be 0. We know that if S is 1, Q will be 0. Q bar will be 1. So that means this is connected to this Q1 transistor. So what happened? So if it is connected, the Q1 will be on. So on means the capacitor will be connected with the ground. So it will discharge. So in the, see, before it was, so I will put in the dotted line. So it's a completed part. So in the discharging part you can see it's a discharge. So you will get the output of like this. So this is your capacitor voltage, this is your output pin at the third. So you can see, again see, this is your high output, again it is going to stable state until if I am giving the next trigger pulse. So immediate discharging because of the capacitor, there is no time constant. Okay, so this is time constant because of the RC value. This is because of the C value. So this is the discharging and the charging. So this is about a, see, I have explained you clear way how this is working. So this is the initial state, it's moving to the trigger state, then it's going to the discharging state, again it's going to revert back. So it's come like this, come like this. So this is a flow diagram how it is working, right? So now if you go to the circuit, clearly you'll understand. See, upper comparator, lower comparator. So initially this will be on, so it will discharge. So this is the discharging path. So when it is connected only, it will discharge. So when your trigger pulse is less than 1/3 of your VCC, this will on. So what happened? This will be on, this will be 0. So this is coming to here. So capacitor will off. So it will be disconnected. This transistor will be disconnected with this capacitor. So this will be charging. It will be charging. So charging, you know, it used to, the capacitor voltage used to rise. Charging. When it will stop, see, it will keep on charging. So when this input, that is the capacitor voltage, is 2/3 of your VCC. See, now this is connected. Where it is connected? Plus is connected to 2/3 VCC, and the minus is connected to the this 2/3 VCC, 2/3 VC. Okay, that means your capacitor voltage, this is a capacitor voltage, if VC voltage is greater than 2 by third of your VCC, they will get the logic of 1. So this is 1 means this will be 0. So then what happened? This will be 1. So this will be given to the transistor, then again it is connected, so it will discharge, right? So you will be having, see, the charging period will be like this, and this is the discharging. So this is the corresponding output, right? So this is a reset. I will explain in the coming slides. Okay, so now we will see the, so I have explained you the in the theoretical part. You can see here whatever I said, it is given. So in the standby state, in the trigger, when it pass, so you can see here Q will be 1, Q bar will be 0. So that means transistor will be disconnected. So through the timing capacitor, it will completely disconnected from the capacitor, from the transistor. So it used to charge exponentially through R and C towards VCC. The time constant is RC. So in the next state, we know that when capacitor is to try to charge towards, so when it reach 2 by 3 VCC by 3, the upper comparator will on, right? The upper comparator will on. So if flip-flop reset to Q to 0 and Q bar to 1, so then what happen, again transistor will be shorted, so used to discharge through this transistor. So this is a complete working process. So this is output with respect to the trigger. So this is a state, this is a stable state, this is a monostable state. When you apply the trigger, you will get. So this is a working process of the monostable. See here you can see the complete explanation of the timing diagram. See, I am giving the trigger, right? When you give the trigger, so when it less than 1 by 3 VCC, the capacitor used to charge. So charging, the capacitor is charging, so you can see that you will get the output like this. So when your capacitor voltage is greater than 1 by 3, immediately the upper comparator is on, so it discharge. So here you can see the Q1 transistor off. Here you can see the Q1 transistor is on. This also Q1 is on. So when it is off, you have a higher logic of VCC. When it is off, you have a higher logic of VCC. When it is on, you have the zero logic. So this is the discharging part, right? So when you see, when very important, when you want to find the derivation, like we take a basic formula for the capacitor. That's what we learned. VC, that is the capacitor voltage, is VCC into 1 minus exponential of minus TVRC. The RC is the time constant, that is tau. So at t equal to t, so that means this is the time period. So at t equal to t, so VCC equal to 2 by 3 VCC, right? So maximum the capacitor voltage is 2 by 3 VCC. I am substituting. So VC, in place of VC, I am substituting 2 by 3 VCC equal to VCC into 1 minus e power t by RC. So I am taking this t as a capital T and time constant RC. Then I am cancel this VCC, then you take this one to the left side. So 2 by 3 minus 1 into e minus e power minus t by RC. Then if you take LCM, you will be getting minus 1 by 3 equal to minus e power minus t by RC. Now take a natural logarithm on both sides. So I explained you step by step. If you take a natural logarithm, so minus minus will get cancelled, so the exponential also will cancel. So we'll be getting minus, if you take a logarithm for 1 by 3, you'll be getting minus 1.1. So then you will, from this, because of natural logarithm, this exponential will get cancelled, then minus t by RC. So then if you modify, if you find still, you will be getting 1.1 RC. So from this you can clearly understand that timing interval is independent to the supply voltage. That is very important. The timing interval is independent to the supply voltage, right? So it is dependent upon RC value. It's dependent on only RC value. So here you can see when your reset is applied. You can see here when the reset pulse is applied, what happened? So I explained you, when a reset pulse is given, so immediately the Q2 is on, right? So when Q2 is on, you'll get the logic 1 is going to the transistor, so immediately the capacitor will be connected, so it will discharge, right? So see here, you can see, so when Q1 is become on, the external timing capacitor is immediately discharged. Understand? So when I am giving the reset pulse, the Q2 is on, so that output is connected to the Q bar. So Q bar output is connected to transistor, so immediately it will discharge. Okay, this then it will be in the same stable state. So it is changed from the higher state to zero state until if it get the next triggering input, it will not change. Okay, the output remain low, very important, the output remain low, that is very important word to understand. Output remain low until the next trigger input is given to the pin 2. Okay, that's what here explained clearly. See here, when you are applying the reset pulse, it is connected, the capacitor Q1 is connected, the logic of 1, so it is discharging immediately through external capacitor, so it's remain in the state of 0 until if you give the next triggering, you will not get the another state. Okay, so when you give the next trigger, you will be getting next monostable state until it will be remain in the 0 state only. So this is a complete working process of the monostable. I explained you what is the basic of monostable, what is the time period derivation, how it is working, how to draw the circuit. I hope this video will be more useful. Thank you.